Good evening, everyone. I warm welcome to all participants and our esteemed resource persons to the Faculty Development Program on Next Generation Sustainable Materials for Eco-Friendly and Durable Civil Engineering Structure. We are honored to have distinguished experts with us to share their valuable insights and equally delighted to welcome our enthusiastic participants whose active engagement will make this program a meaningful, learningful experience. Together, we look forward to enriching discussions, knowledge sharing, and innovative ideas that will contribute to sustainable and durable practices in civil engineering. Wishing everyone a successful and insightful FDP. Now I am welcoming our expert. Good evening. Good evening, sir. We are honored to welcome Mr. Ramesh Singru, a seasoned infrastructure professional with over 35 years of experience in executing large-scale projects across India. He has successfully led projects worth over 20,000 crores in sectors such as highways, metro rail, bridge, tunnels, ports, power plants, and urban infrastructure. Mr. Singhu sir combines deep technical knowledge with strong legal, commercial, and financial acumen and has worked under various contract models including HAM, BOT, EPC, and TOT. He currently serves as a regional head Mumbai at Navyog Engineering Company Limited and has previously had key leadership positions including CEO and KMC contributions and head of projects road division at Adani Group. He holds degree in civil engineering, transportation engineering, and law, making him a truly well-rounded industry leader. Let us extend a warm welcome to Mr. Ramesh Singh sir. Finally, I request our expert, Mr. Ramesh Singh sir, please take over and begin the seventh session of this FDP. Thank you all for your presence and support. Please, sir.
Yeah, thank you so much, madam, for your kind words and the appreciation you have shown towards my profile. I really appreciate that. So, good evening, everyone. It's pleasure to be here today. I want to extend a warm welcome to our distinguished guests, faculty, students, and partners. Your presence here is a testament to our shared commitment to innovation and progress in the field of civil construction. I would like to take this opportunity to thank Dr. Gopinath, Archana Madam, Shivani Madam, and the MITS team for their concerted efforts in taking this initiative and program forward. Before we dive into the core of our discussion, I would like to introduce myself. As Madam has already introduced that I am the regional head in the Navyog Engineering Company at Mumbai. I have been a little background of myself. I have been into this industry for more than 3 decades and have been executing projects. I have done dozens of road projects, metro projects, then tunnels, bridges, airports, then petrochemicals, petroleum refineries, thermal power plants, solar power plants, windmill power plants, so many other projects, including many industrial buildings, etc. So this is a varied experience, and it's very fortunate for me to gain this kind of experience over the past 3 decades. So I'll be sharing some valuable insights towards this subject today going forward. So the presentation you are about to see titled Next Generation Sustainable Materials for Eco-Friendly and Durable Civil Engineering Structures. See, this sentence itself speaks a lot. It is next generation sustainable materials for eco-friendly and durable civil engineering structures. The statement is simple, but the meaning is voluminous, which I'll be briefing in the further of this session. So it's not just a collection of data. It is vision for the future. It reflects shift in thinking, a move away from conventional methods and towards more sustainable, efficient, and economically viable solutions. I mean, more sustainable, efficient, and economically viable solutions. Here also, there's a lot of meaning in this. And one more important thing is, I want to touch the subject on the ESG. ESG is an important aspect to be delved in this subject, which will be discussed in the subsequent slides. For decades, we have relied on traditional materials and processes. But as the world changes, so must we. So the scarcity of natural resources, the pressing need to reduce the environmental footprint and the constant demand for cost-effective infrastructure are forcing us to innovate. We have to innovate. This is not a theoretical exercise. The concepts we will discuss are being implemented right now, yielding tangible results. We are seeing real savings and real environmental benefits, and we are building a more resilient infrastructure for the generations to come. Over the next 1 hour, we will take a deep dive into 12 key areas where the innovation is taking place. We will start with ultra performance concrete, and we will also discuss about vast crusher sand, and we will also examine the immense potential of switching from diesel generators to grid electricity and how solar panels and toll plazas can generate significant savings while reducing the carbon footprints. So our journey continues as we look at how byproducts like fly ash, GGBS can replace partial cement content in concrete, leading to substantial cost savings and improved durability. We will also see how modern materials like mastic sheets and geocomposites can offer superior, most cost-effective alternatives to traditional asphalt and aggregate filter media. We will then explore exciting advancements in pavement design, from the benefits of thin white topping to the revolutionary use of reclaimed asphalt, pavement material, and other cost-effective layers. These innovations are not about saving money, they are about building smart, stronger structures. We will discuss how we can turn plastic waste into a valuable material for asphalt mixes and environmental problem resolving in practical solutions. The data presented today will show that embracing innovation is not just the right thing to do, it's the smart thing to do. It's about creating a better world. So, with that in mind, let's begin this first topic and start this program. So, I will go one by one. So, let me tell you a small briefing about all this. I do not know how many of you are aware. The technology is advancing so rapidly that I should say that it is going faster than the human requirements. If you have heard about Stephen Hawking is a renowned scientist, astrophysicist, who is known to be the second most intelligent human being on this earth after Sir Albert Einstein. So, this scientist has recently passed away, recently means 3-4 years back. He is the person who has made a bold statement before his death that the technology is advancing beyond the human requirement. But at the same breadth and depth, though it is going beyond the technology, unfortunately, we are not even touching 10% of the new technologies. So, exploring the new technologies is the need of the hour. I would always say that the institutions, it may be an IIT or an MIT or an NIT or any other technical institutes, the faculty over there, the research students over there, and the final year students there, they should join hands, they should think of these new innovations, and they have to come out with new startups. I will tell you, the humankind requires lakhs of new startups. It's not thousands, lakhs of new startups. So everyone thinks about a job. After completion of their graduation, they will immediately think that I should get into a job. Yes, that's a good thought. It's not wrong. Getting into the job is always good because you have to support yourself. You have to feed yourself. You have to support your family. So a job is very much required. But at the same time, the job, what you think is, you always think for the money. Means some earnings. Earnings not for becoming rich or something, but to make our life, for our livelihood. But I suggest that all the young engineers, including the faculty members, should put their minds and think about the innovative ideas, innovative solutions, innovative materials for the generations to come. Now, if you see what if you look at, if you examine the slides, what I'm going to discuss, you will also develop some idea. You can also, idea is not something got from some textbook. Idea is it's come from your brain, I mean your thinking. So you can also think and you can also come out with innovative solutions. So this is only my suggestion. I'm not telling that the young engineers and students should not aim for jobs. Please do your trials for jobs, but who are enthusiastic, who are energetic, who are looking forward to grow faster and who want to serve the nation. See, growing faster is not important. Serving the nation in building assets for the nation. Now, if you take my case, I have been working for this construction industry right from from the day I came out of my college. I joined a company, and from that day till date, I have been continuously working non-stop. So this 35 years of span gave me a lot of learning. Of course, the 4 years of theory, what I learned during my engineering, that is one part, but this 35 years of learning is the second part. So, like how we talk about doctors who graduate, who become MBBS, and they do their specialization PG and all. So for them, the clinical exposure is more important. Now we'll go to the main subject. Let us start the main subject.
Synthesis. Can you remove the slide? Sir, Ramesh can upload the PPT.
Yes. We'll upload the PPT.
Instead, I remove it.
Put it slide sharing. Yeah. So I will not take much time. I only wanted to give a small introduction. So I think I have bored you people by giving the introduction. But let me start the.
No, sir, Ramesh, make it bigger.
Yeah.
Slide.
Now see, if you see, is my screen visible?
Visible, but 2 slides are coming. Only 1 slide.
No. I'll go one by one. This is only an introduction.
Okay.
This is only introduction. It's only introduction. I'll go one by one.
Okay.
I'll go one by one. See, I am going to discuss on 12 topics. Serial number 2 to serial number 13.
Right.
So these are the 12 topics I'm going to cover. I'll try to cover it very quickly, but they're very interesting for all the, it's not only interesting for civil engineering, for mechanical, electrical, for everyone, it will be interesting. So if you see the left-hand side, there are 3 photographs. All those 3 photographs are live photographs. The photographs of the Indian engineering, innovations or the designs and the construction by Indian engineering companies. The first photograph is in Hyderabad at Durgam Cheruvu, the cable stayed bridge, which was done by L&T. The second photograph is of Bandra Worli Sea Link in Bombay, very famous, constructed by HCC. And third one was done by KMC in Tripura. So these are all jobs which have been done with this innovative and this new generation using new generation sustainable materials, etc.
Ramesh, small suggestion. Can you
Yeah.
make the screen full screen? Actually, it occupies to.
No, it is.
No, you just observe. 2 slides are visible.
For us, it is in full.
Now it is okay. Now it is okay.
So is it now in full screen?
Now it's full screen. Now it's full screen.
Yeah. Now see, you want me to repeat this slide once again?
No, not required. Not required. We saw it, but only just.
So I'll just tell you ESG. Why I am talking about ESG? ESG means environmental social governance. I want to tell everyone who is present here, ESG is the need of the hour. Every company has to be ESG compliant now. If any bank has to give any loan or any any lending company, any fund-based company want to give a loan to a construction company, they have to be ESG compliant. Then only they are giving loan. Even many foreign funds are subject to the ESG compliance. So ESG is important. This subject is related to ESG. That's why I'm talking about ESG. What is ESG? ESG means environmental social governance. It includes including evaluating the company's corporate climate policies, waste reduction, pollution control, toxic waste management, energy use policy, natural resource conservation, animal treatment, and environmental compliance. These factors help you know the company's commitment to environmental well-being. This is a very important aspect. This is what, on this basis only, we are going to take our presentation forward. Then the social impact involves assessing an organization's stakeholder relationships, CSR activities, employee treatment and satisfaction levels, workplace welfare, etc. It shows how committed and responsible the company is towards society. Then governance. This is associated with various elements like honesty, transparency, integrity, leadership, and so many important things. So these three are very, very essential for the ESG compliance. Now I will start the main subject. This is the main subject. I'll start with the ultra high performance concrete. So I want to tell all the viewers and listeners that the code for this is only a French code. There is no Indian code yet. The IRC is expected to release its code in due course of time. IRC, I think you are familiar with IRC codes, the Indian Road Congress. They are most likely to release this code very soon for the industry. However, the current designs are happening as per the French code, that is NF P18710 and P18470. UHPC stands for Ultra High Performance Concrete, an advanced cementitious material with exceptional compressive strength, high post-cracking tensile strength, improved ductility, and excellent durability, achieved through a low water cement ratio, dense packing of fine granular constituents, and there will be no coarse aggregates. No coarse aggregate means you are again saving the environment. You are protecting the environment because you will not have to do much quarrying. If you are not doing quarrying, that means you are reducing the pollution. You are protecting the environment. So the coarse aggregate usage will not be there here. So that is what this UHPC says. And steel fiber reinforcement and brittleness make it suitable for demanding infrastructure applications, but its use can be limited by cost and design codes. So it is, the compressive strength of this will be 140 to 220 MPa. Now, if you see the characteristics, as I said, it is high compressive strength. Ductility exhibits a strain hardening behavior after cracking, meaning it can sustain tensile loads even after it's cracked, unlike brittle conventional concrete. See, if you see conventional concrete, when it cracks, it will not take the tensile load, but even this cracks, it will take tensile loads. That is the beauty of this product. Then durability. Its discontinuous pore structure reduces liquid ingress, leading to enhanced resistance to chloride and a long lifespan. High flowability. The material has excellent workability and self-compacting properties, eliminating the need for compaction. Yesterday, somebody was asking whether it is self-compacting or not. Some question was put. So this is self-compacting, it has self-compacting properties. Then dense microstructure. It lacks coarse aggregates and uses optimized proportion of fine granular constituents like Portland cement, silica fume, and fine sand for dense packing. Fiber reinforcement. The main ingredient is the fiber reinforcement. Discontinuous steel fibers are incorporated to improve post-cracking tensile, tensile strength and ductility. See, here, you can see the point. What I want to impress all of you is generally what happens. The AICTE does. They have a limitation. You cannot use it for 50 meters or something. But here in this case, it can be used up to 100 meters. You can use you can use spans up to 100 meters. I'll show it in the next slide. See, it is superior mechanical property, offers signal higher compression, improved durability, and leading to longer service life, and non-brittle, provides better performance, resisting brittle failure. Its application is in bridges for piers, decks, girders, link slabs, etc. Infrastructure, it's used in buildings also. Then specialized structures, conventional concrete cannot meet performance requirements. Sustainability, possesses a better ecological footprint than other materials and allows for longer lasting structures with lower material usage. See, the advantages due to reduced section, thickness of flange and web, the weight will reduce by almost 50%. So that is one big advantage. So the reduced weight per meter helps in designing longer spans. You can design for longer spans up to 80 meters and 100 meter spans. So that is the biggest advantage. If you want to go with normal RCC in concrete, you cannot go up to that long spans. That is the advantage of this high UHPC. And the cost incurred for execution of pile caps, pier cap, etc., that also will reduce, because when your span is more, your number of piers, number of pile foundations also will reduce. So automatically the cost will come down. So as I said, it can be used up to 100 meter span. Recently, 1 or 2 meter span has been used in one of the locations. And as I said, steel fibers are induced inside. So smaller lengths of 20 meter by 3 span can also be used for to suppose we have a transportation issue. We can make it in smaller spans and we can transport it, and we can do the post tensioning at the site location. So that is also one advantage is here. You can see the composition. See, the composition is cement 898 kgs, silica is 200 kgs, silica fumes then silica fine sand is 500 kgs, then silica medium sand is 500 kgs, micro steel is 157. This is what I was talking about. Then admixture is 37 kgs. In powder form it will be there. If you see, the cost per cubic meter is around 47,000 cubic meters, whereas the conventional concrete cost will be around 5,000 to 6,000 rupees only. You may put a question, when it is so costly, why should we go for this this thing? I think this we will leave these questions for answering at a later stage. So this is the typical cross section. You can see the top cross section where it is this thing. What do you say? Let me put the pointer also. You can see this is the ultra high performance concrete, whereas this is conventional. So this will be the cross section. You can see here the self weight. You can see the gutter depth. You can see the cross section area. All these things will come down. You can see for different spans also. You can see what will be the self weight, what will be the gutter depth, what will be the this thing. That is also mentioned here. So you can see the typical plant of a ready mix plant of a ultra high performance concrete. And if you see the table below, you can see the suppose there is a pile foundation of 1.2 dia. If in conventional superstructure, if you are using 56 numbers of piles, if you use UHPC girders, there you will require only 24 numbers because you are increasing the span. So reduction is scope. Scope is reducing by 57 numbers. So then your pile cap is 789 numbers. 434 pile caps are enough. Piers 100 here, 45 are enough. Then abutment same will be pier caps 181 pier caps you can reduce by 72. Superstructure of 1070 cubic you can bring it down to 750 cubic meters. So these are the savings. And you can see this, these are the steel fibers. The dia of the steel fiber will be 0.2 mm and the length will be around 13 mm. They are with copper coating. Copper coating is provided for chloride resistant, sulfate resistant, etc. And also for any, corrosion, etc. See, these are the finished products where they have been launched in different locations. They are being used. So whenever you can see here also Dharmapuri, they have done 1 or 2 meters. See, why I am talking about these spans is, I'll tell you, if you see the obligatory spans constructed in cities, in metro cities and all, there will be obligatory spans. In obligatory spans, what will happen? A flyover will be there. In between, there will be openings, huge openings where there will be a 4-lane, 6-lane road and all will be passing. So there will be no obstruction. So in such locations where you want to do obligatory spans, you can use the long spans. Also, where if you want to use it for a bridge where there is a water stream, you want your discharge, you want your flow of water uninterrupted. There also you don't want any piers in between. You can use this kind of long span girders. So like that, in those locations, you cannot use the normal the RCC or PSCI girders. So this is the advantage. By reducing your number of piers, by reducing your number of piles, etc., the cost will come down. However, there may be a slight saving, but there will not be abnormal saving, but it will be technically it is very advantageous. That is the biggest takeaway in this UHPC. So this is being largely used by many construction companies, including L&T, Navyuga, HCC, many good companies, Afcons. They are using these kind of things for different specified applications. Some special structures they are using where the span is higher. So, and even you can use in the railway spans also, where there is a ROB, there also you can use this kind of spans, because in railway bridges and all, there should be no interruption. There will be no pier or anything in between. So that is about the UHPC. Now I will come into the next topic, the geocomposite in place of aggregate filter media. See, this is very important. See, filter media is one important material. It's normally aggregate, it's stone aggregate. So again, you have to do quarrying. That is that stone quarrying is it is again environmental concern. So that stone quarrying will not be required. That cost also will reduce. The time also will reduce. So there are many advantages, and application is also very simple. If you see the left hand side picture, this gray color one is the geocomposite. So just fix it there. So and you can fill with your soil. You can fill with soil. There is no more filter media required there. And at the bottom there will be one perforated drainage spout. So whenever there is a what you call flooding or rain or anything, the water will pass. I mean, it will flow through the permeable soil and it will enter into that drainage spout and it will get drained off. So this is an effective solution, And the material here is also being used as HDPE, high density polyethylene. So there is no plastic, and you can reduce the what you call quarrying, and that's what I told initially. So this is also one of the ESG measures, what I told in the first slide, ESG, environmentally friendly. So next slide is, again, there is a reference code also for this. It is SP59, and the railway code also is there for this, RDSO IRS 0006. The combination of geotextile, a permeable fabric like synthetic material typically made from polypropylene or polyester, at top and bottom, and geonet made of high density HDPE or polypropylene center. So geocomposite application. The geocomposite drainage system installed behind the river, which I explained earlier, it will be at the bottom, behind the walls. You have to prepare the surface, and then place the geocomposite, secure the panels. You have to secure panels when you are fixing the geo. You have to secure them. You have to nail them. So that is so that it will not slip. Connect it to the outlet. Then backfill with the soil. So this is the typical application. I don't want to read out everything, but I just wanted to brief you step by step. You see the conventional one. If you see the conventional one, see, this is the filter media. This is the stone aggregate. So you have to excavate, you have to bring the stone aggregate, you have to dump it there. That is a cost. All that headache is not there, and it's enviro friendly. If you see, you can see the cost comparison also here. If you go for filter media, suppose for 5,000 square meters, it's costing you 90 lakhs. Here it is saving of 15 lakhs. There is a cost saving also. In fact, I want to tell you, we use this in the state of Tripura. So in fact, we had designed this through the CRRA, Central Road Research Institute, and we used it for a 48-kilometer stretch in Agartala. Agartala to Udaipur. Udaipur is a city, town in Tripura. From Agartala is the capital of Tripura. We used it. It was a very successful, and it's performing very nice. Now I'll go to the next topic, the geocells. This is also another interesting, innovative, sustainable material. So it is used in stabilization of soil to control erosion, to reduce GSB, wet mix, when used in pavement, slope protection, retaining walls, and canal lining. So no need to advantages, no need to execute aggregate filter media, 300, cost saving, time saving, dependence on stone quarry and crushing. So many benefits are there. Boulders are not required for slope protection when geocells are used. See, again, stone boulders, that is also not required when geocells are required. Quarrying also can be avoided. It's again environmentally friendly. And it is also relevant to IRC SP59. It's perfectly mentioned in the code. You can see the typical picture, how the geocells are applied. See, in the olden days, preparation of the slopes, that was a cumbersome exercise. And then we have to bring the stones, and we have to bring the skilled masons. They have to place it. There is a risk of injuries, so many things. Nothing here. Just bring the geocell and just lock it at the top and bottom, and just do the vegetation. See, site preparation, geotextile placement, the geocell placements, anchoring the geocell system, and filling the geocells. It is so simple. So you can see after some time, when you what they call choose the infill material, like some vegetation or something, it will become totally green. It will look like a cricket pitch. So green and very elegant, very eco-friendly. It will generate a lot of oxygen, reduction in the carbon. So these are all ESG compliant and technically proven and easy to apply, easy to transport. There is no requirement of any stone quarrying. A very innovative solution. See, you see the difference. You see here how the stone pitching, how cumbersome. And if you do the stone pitching also, again, you cannot do any vegetation and all. Whereas in the earlier slide, you can do the vegetation also. And it's looking good. And this total slope will get stabilized. It will not, it will, because of the vegetation roots penetrating deep inside, it will become very sturdy and very rigid. It will not slide. It will not even slide. Again, if you see the cost analysis also, I mean, I wanted to get some cost analysis also into this presentation for a 1 kilometer length. Say 5,000 square meters, that is 1,500 cubic meters. If stone pitching is costing 7,50,000, stone pitching is costing 45 lakhs, geocell will cost 37 lakhs 50,000 is savings, huge savings. This was used by us in one of our projects in Kerala, near Thrissur. And also we used it in Tripura, in state of, in Agartala, in the state of Tripura. So these are very innovative, very eco-friendly and easy to fix them, and no much labor required. And they are also, in line with the codal practices. Next is the geocomposite and fabric. These are the two items. One is geocomposite and one is paving fabric. What is geocomposite and its applications, and what is paving fabric and its applications? See, geocomposite is an engineering material combining geosynthetics and that is geogrids and textiles to provide multiple functions such as separation, to separate two layers, and to provide filtration, and also to provide drainage and protection against water intrusion. These materials are used as drainage layers in stabilized soil to prevent water from damaging the road structure and enhance overall performance and longevity. I will tell you one single short example. In a typical road crust, there will be a subgrade, there will be a subbase, and there will be base and DBM and BC. What happens is this subbase is here, this subgrade, then top of that there will be a GSB layer, that is granular subbase. That is normally in any crust design, it will be 200 to 250 mm thickness with 40 down aggregate or something. So what happens is, again, the stone aggregate requirement is not there. You can straight away spread this geocomposite, and this geocomposite layer will act as a drainage layer. So your crust thickness will reduce, and also it will provide the filter media, that is the drainage layer. Suppose you use it in a road. If the water during heavy rains and all, or during flooding, if the water is there in one side, the water will pass away through the this particular geocomposite layer to the other side. It will not disturb the road crust. That is the main advantage of geocomposite. And of course, time saving. You need not do quarrying, you need not transport the stones, you need not place it there, you need not do the compaction. So many operations can be avoided. And it is time saving, not only cost saving, time saving, and eco-friendly. So many advantages are there in this. See, cost effectiveness, soil stabilization, users on site, locally available soil, reducing the need for costly procurement new aggregates. It can also reduce the required pavement thickness, lowering material cost, which I told you. So GSB requires you have to bring the quantities, large quantities, you have to do the crushing, it's very expensive. Then environmental impact, the carbon footprint will be minimized here. There, it's lots of waste disposal, fuel consumption, diesel generators will be working. So that is a environmental effect. Then durability, this is more durable. It increases the soil strength also. So that is susceptible to water damage. And time, as I said earlier, time, the construction time. Suppose you want to do 1 kilometer, that one, if it takes 10 2 days, 3 days. This will be over in 2-3 hours. Where is 3 days and where is 2-3 hours? There's a lot of difference. There's a lot of time saving, apart from your cost saving. Then the paving fabrics. See, if I go back to this, the second one is the SAMI layer. SAMI layer means stress absorbing membrane interface. This is stress absorbing membrane interface will normally be below the DBM, that is dense bituminous macadam, and the WMM. Between them, this SAMI layer will come, because on top of the wet mix macadam, this SAMI layer will come. On top of that, this DBM layer will come. So the idea is to prevent the surface cracks penetrating into the DBM layer. So the bituminous layer, automatically the road will perform good during wear and tear. If these cracks are penetrating to the DBM, then the road will get damaged. So conventional method is going with the stone aggregates and all, the SAMI layer, but this paving fabric is a advanced technology. You can see this typical, these are all mentioned again in IRC code SP15A, the geocomposites and paving fabrics. You can see the various options. For 50 MSA, we have used in northeast, option 1, option 2, option 3, 300 thick, 900, 600 thick, 900 in the option 1. The option 2, it is 250, 500, 750. If you see the option 3, it is 250, 500, 750 and 1000. So I mean 750 only. So it is drastically, the thickness has reduced. So this also we have used in the state of Tripura. See, for different, this MSA. MSA means, I think you know, that is the roads are designed for MSA. 50 MSA, 75 MSA, 100 MSA. So if you see here, I made a small cost comparison for option 1, 2, and 3. In option 1, if you see, the cost per kilometer is 6.98 crores. Whereas if you go with the option 3, by using this geocomposite fabric, it's coming down to 3.71 crores. Your product is eco-friendly and your cost is also coming down. At the same time, there's a lot of time saving. So a lot of benefits are there in this. So my point is, we have to adopt all this. Already this is widely being used. In fact, I want to proudly say that when I was a CEO of my previous company, I took the initiative, and I have done the tests, etc., CRRA with my team, and we were successful in this, and we have done this project in the state of Tripura for 48-kilometer stretch, and believe me, it's almost 10 years old. There is no iota of any damage till date, and it's a totally rain-prone zone. Even then, there is no damage. It's performing very well. So this has been replicated across Northeast, and now it is widely being used in every project, because there's a lot of crisis in the market for stones, because quarrying has been restricted. Quarrying in every state, there's a lot of restriction because of environmental concerns, local issues. People are objecting to quarrying because there's a lot of noise pollutions, there are a lot of accidents, etc. They are not permitting. So stone quarrying has become a highly restricted activity. So these innovative solutions are giving good results as well. It is saving the time and cost. So, and also environmentally friendly. You can see, these are the practical applications of the geocomposite during the laying. How easy it is. It is simple. Just it will come in a roll. 2 labor will be there. Just roll it and spread it. So the labor component is also bare minimum. It's very easy to apply. You can see the fabrics, playing the fabrics on the DBM layer. Next is the wrap. reclaimed asphalt pavement material in wet mix and the asphalt mixes. This is also as per IRC 120. This is also widely being used and is very important. And if you see, it can be utilized for WMM replacing portion of the natural aggregate after analyzing the material to ensure it meets the required gradation and technical specifications. Studies show that incorporating 30% RAP of the total mixture can reduce fresh material usage, lower construction costs, and promote sustainability. However, careful mix design, testing, and potential addition of missing aggregate fractions are necessary to achieve the desired load-bearing capacity. So, the application process, material analysis. The RAP is collected from milling payments. I think many of you might have seen there will be milling machines. So, the milling machines will mill and take out the RAP material from the existing flexible payments. So, that RAP material will be used for this RAP mix. So, the RAP is blended with natural aggregates and it's sent to the mixture. Again, see, whenever we are using this RAP, we have to do the mix design. Mix design should be conducted and the test results have to be examined. And if they are within the range acceptable norms, then only that mix has to be used. So why mix design is required? Because the percentage of the ingredients will be decided. Sometimes RAP may be decreased, sometimes RAP may be increased, or bitumen percentage may be decreased, bitumen may increase, or filler may be increased or decreased, binder may be increased. All these combinations will be worked out. See, the performance while RAP increases stiffness, a carefully designed mix can maintain or even improve load-bearing capacity and durability. So you can see per cubic meter, we just made a simple analysis. How much of cost saving is visible? Almost 576 rupees is the cost saving in the entire process, including we have taken the milling cost also. We have taken the milling cost, everything has been calculated. If you see, if you go with the conventional process, it will be 2,300, whereas it is 1,700. See, these costs are depending upon the place to place. Some places aggregate cost may be more. Some places, what you call the bitumen cost may be more because of transportation. So all that you have to, this is worked out at a particular location. This cost, in some projects, the cost may be that 2,300, maybe 2,000, or even 1,800, or even 1,500. It all depends upon this ingredients, the cost of the, but this particular cost is we have used at a particular project, we have made that analysis. However, you can see the savings. So with the appropriate controls, correct proportions, ingredients, and the employment of adequately equipped plants, it is possible to produce an excellent conglomerate which is no way falls short of the mixture obtained using only virgin materials. Generally, it is recommended to use high RAP percentage in the lower layers of the payment. That means in the lower layer of the payments, you can use high RAP percentages. While in the surface layers, which are easily ruined, it is preferable to use very low percentages or better to avoid. The knowledge of the aggregate in the RAP in order to identify the type and quantity of the virgin aggregates required to integrate the grading curve. The knowledge of the bitumen content in the RAP, yes, this is very important. As it is aged and therefore has a lower penetration than the original virgin bitumen, it is also harder because during the mixing phase in the plant and during its life in the road payment, it is subject to oxidation processes, which after its properties, which alter its properties. Hence, when employing RAP, the higher viscosity of the older bitumen might also give a certain resistance to mixing. Therefore, the properties of the bitumen in an asphalt mix during using RAP is balanced by adding correctly graded virgin bitumen. So, RAP was used in Kerala and again in Tripura. See, you can see the typical flow, how a wrap is this thing. You can see in the left-hand side here, you can see the normal, in the normal bin, cold, we call it cold bin, means a normal bin. In that, the aggregate is poured, then it will go to the dryer. From there, necessary screening will happen. And there will be one more bin where the wrap will be collected and dumped. That wrap will come into the mixture, and bitumen, as per the mix design, the bitumen will be added, and the bitumen mix will come out. This is the dry method. And if you see the other method, it's a way we call it a wet method. You can see here, wrap is also heated. The difference of that slide and this slide is here, wrap is also heated, and it is passed, and the bitumen is mixed, and mix will come out. So both are, used. And the temperatures, at what temperature they have to be 130 to 140 degrees centigrade. In case of this one, it will be at 35 to 40. So all these temperatures are also defined. So again here we have bought the relevant codes, the benefits, technical benefits, and also the time saving, the time saving elements have been discussed, and the cost. So if you see here, total savings, bitumen plus aggregate, option 1, 2, 3. There it is nearly 4,285 rupees is saving, because your wrap content has increased 50%. So 4,285 per cubic meter is a big amount. So this is a solution for what we call the eco-friendly material, the environmental balancing, the time saving, cost saving, and technically viable. All four parameters are met here. See, I'm just showing some typical photographs, how the laying of wet mix macadam is done, and how it is compacted with the tandem rollers, asphalt mix machine, the laying of asphalt, and the sensor pavers, and these are all the tandem rollers. These are all the PTRs. PTRs means the pneumatic tire rollers. It will give the finish of the road. This is another photograph. So this is now coming to plastic wastage. So plastic wastage is a big concern. It's a global concern. Today, if you see everywhere, plastics are very widely used, and they are dumped in different garbages, and the local municipalities are facing a challenge in removing them from the cities, from the communities, etc. So now collecting all this plastic waste, and doing some recycling and using for certain useful applications, it will reduce it is environmental friendly, it will reduce pollution, it's also cost effective, and also time saving. More than time saving, it's cost effective. You see, and one more thing, however, the permissible limit is only 8%. You cannot go 8% beyond the weight of bitumen, not 8% on the total volume of the mix. It is the limitation is 8% to the weight of the bitumen that is being used in the mix. That is the limitation. So waste plastic, low density LDPE is used. When LDPE, what is LDPE? Carry bags, sacks, milk products, bin lining, cosmetic and detergent bottles. HDPE is carry bags, bottle caps, household articles, etc. Polyethylene terephthalate, PET we call drinking water bottles. Polypropylene, bottle caps, closures, wrappers, biscuit packets, etc. Microwave trays. Polystyrene, yogurt pots, etc. Food trays, egg boxes, disposable cups. Polyvinyl chloride, mineral water bottles, credit cards, pipes, gutters, and all these things. all these things for them, they are a dry process, this is the wet process. So approximately 1 ton of waste plastic is consumed in one lane of 3.5 meter per kilometer of NH construction. About 2,900 kilometers of NH length has been already constructed using waste plastic. But I'll tell you, I do not know how many of you are aware, there's a huge road network in the country. It is, I think, if I am not wrong, it is more than 3 lakhs kilometers of network is there in the country. And we are targeting to enhance it by another 2 lakhs next coming 5 years. So we have utilized only for 2,900 kilometers. So you can imagine how much of plastic waste can be utilized in these purposes, which is eco-friendly and also cost-effective and technically acceptable solution. You can see how the blend is there in the pictorial this thing demography. The preheated aggregates, then the plastics which are cut into pieces, those two are used in the mix. Then the heated bitumen is mixed and it is mixed in the asphalt mix, and the mixture will mix it. Again, this also will happen as per the mix design. So there are two processes here, again, dry and wet process. This is the dry process. So typically the size, the micron size of the plastics will be around 600 microns to 2.36 mm. And the temperature at which they are to be heated is 165 degrees temperature. So this is what the ingredients mix looks like. If you see the next one, it is a bit different. We call it, this mix is called the polymer modified bitumen. So here heated bitumen is there, the shredded plastic waste, they are blended with this thing, then preheated aggregated as in bitumen is mixed in, that is called the PMB. So this is the wet process. The earlier one was the dry process. Here also the preparation is done at a temperature of nearly 170 degrees centigrade. So wet process advantage is a bit expensive, normative guidance and engineering experience. Drawback is complex production process, specialized mixing and storage facilities. Advantage, high viscosity. Drawback is poor storage. Dry process cheaper, lacks normative guidance, and drawback is simple production process. And drawback is performance of mixture. Drawback is poor water stability. If you see in the cost perspective, if you see bitumen percentage is 5.4, and if you use 8% of, because 8% is maximum limit, so 8% means it will come to some 4.9%. That means where you are using 132 kgs, it will become 122. So there is a saving of 10. That is almost, its a total overall saving will be 600 rupees per cubic meter by using this plastic. That is the advantage. Now this is use of fly ash and GG. I think this topic was covered yesterday and day before yesterday. A couple of our colleagues, research colleagues, friends have shared. They went on a individual topic. I am trying to cover multiple topics. So I do not know whether it is interesting to all of you or a bit boring, but I wanted to share in more constructive perspective, because I am not a design engineer, but yes, I am a true project management professional, and I can share my construction exposure in detail. If you see doctors are cardiologists are there, orthopedicians are there, then child specialists or pediatricians are there, but there is a general medicine doctor. Now you can call me a general medicine doctor in construction. I am there everywhere. But if you put some design questions, I will have to, I will have to get into the designs and discuss with the design team and answer. But general questions, yes, I will definitely answer. There's no, issue in that. It's just I am telling in a lighter vein. Now coming to this fly ash and GGBS, 1489, the code reference is 1489 and 1674. Both are IS codes, and IRC SP 58 is also there. So this is very, very widely used, fly ash and GGBS. So I think many of the construction industry experts are using in almost all of their projects. So this is one important material which is also it is saving the environment in many aspects. Now, for example, let's say fly ash is a powdery waste from coal-fired power plants, and the thermal power plants. Its slag is a molten waste product from the steel. Slag is from steel making process. So fly ash and slag waste from thermal power plants and steel factories causes environmental problems, including land contamination, groundwater pollution from heavy metals, air pollution from fine particles. Since if this fly ash is not properly, used, or if it is left like that, and if the particles fly, there are a lot of diseases, TB and all, so many effects may impart to the human being. And the negative effects to the soil quality also. It poses health risks to humans, as I said, respiratory issues, cardiovascular disease, and increased cancer risk. So we are eliminating all that. We are straight away taking that and using it for our concrete mix designs. We are reducing the cement content, and we are using this fly ash. Similarly, we are using the GGBS also. I'll explain in detail. Now come to pond ash. Pond ash is a little different. Pond ash is a mixture of fly ash and bottom ash, coarser ash that falls to the furnace bottom, transported to ash ponds with large quantities of water, forming a slab. It is a coarser, more porous material compared to fly ash and requires large storage area. So, and a lot of, only transportation cost will be applicable here. So this is about the fly ash and this thing. I'll run fast because of time constraint. I'll just go to this key features. We are already using in our Pune ring road. Currently, we are using it. If you see how, you can see what are the various this thing. This is a mix design which is approved after several mixes and all. You can see the in OPC, if it is 300 kgs, if you go for fly ash, it's 240 kgs. I'm just telling for different grades. For M20 grade, it's 80 kgs. So you can see the cost saving, 3,16,000 rupees. So it is environment friendly and cost saving, and also the blend of the concrete also will be very good. So like that, it is for different grades. Then GGBS, that is ground granulated blast furnace slag, is a byproduct, as I said, it's a byproduct of steel industry. So here also it reduces the carbon emissions, improves resistance to chloride ingress and sulfate attacks and thermal cracking and all. It is used in various infrastructure projects, including bridges, tunnels, foundations, and more sustainable, durable structures. It is a partial replacement of OPC. It increases improves fresh concrete properties, making it more workable, and can reduce the amount of water with super sizes, class sizes needed. You can see here also M20 grade. You see when using GGBS, if it is 300 kgs, you can go with suppose 230 kgs and 90 kgs of GGBS. Here also there is a cost saving. This GGBS also is being used in our Bombay in one of the projects in Thane. Now this is one new important thing. All of you, I know all of you are aware that solar projects are happening, but interestingly, the solar panel concept is growing very fast. I want to tell you now, the Cochin airport, they have installed 50 megawatt of solar panels. You can imagine 50 megawatt in one airport. So it is very, very environmental friendly. There is no pollution at all. So reduced greenhouse effect, improved air quality, water conservation, reduce land degradation, less noise pollution, whatnot. So many advantages. So I don't want to get into the description and all. I am just telling you the brief advantages. It has been used in even road project in Toll Plaza in Gujarat and Tamil Nadu also. You can see solar power is the energy from the sun that is converted into usable heat or electricity using technology like photovoltaics and concentrated solar power. Photovoltaic PV cells directly convert sunlight into electricity, while concentrated solar power uses mirrors to focus sunlight to heat a fluid, which then drives turbines to generate electricity. It is a clean, renewable, and abundant energy source with diverse applications from powering single homes to large energy plants. So, as I said earlier, the thermal power plant, lot of fly ash comes, pond ash comes, but that is being used in other cement manufacturing and road sector, etc. But in solar panels, it's a clean energy, green energy. There is no requirement of any this thing. It is a direct environmental friendly. So in India, installing a rooftop solution system for a commercial or industrial facility like a toll plaza costs around 35,000 to 50,000 per kilowatt. So low carbon benefits, low carbon footprint, sustainable infrastructure, and government also is encouraging. Government has been supporting this all new initiatives are being even funded. Government is giving funds also for all such new initiatives. You see, just a typical this thing. If you see with for a 200 kilowatt, it's if suppose cost is 18.74, here it's 37.49 lakhs. But you see the carbon dioxide reduction or metric ton per year. Here in the first case, it's 240 metric tons, and the second case is 480 metric tons. This is the beauty of this power generation. So I want to tell all the viewers and listeners that as I said, I have executed thermal power plants, I did solar power plants, I did wind power plants. The potential in this country for the power generation is only in solar in the next 5 years is 500 gigawatt. 500 gigawatt is the potential, and in wind it is 200 gigawatt. In thermal is also, I think, somewhere about 100 or 200 gigawatt. So there's a vast requirement of power. So we have to become more greener and greener. So we have to encourage the solar power, wind power. Then in Sydney there is a power plant with waves. The sea waves are being used for generation of power in the city of Sydney in Australia. So these innovations, that's what in my opening address I was trying to impress the viewers, that the innovative technologies have to be used, and also the mind has to be blown up to explore new ideas for these type of innovation. This is a benefit to the human being. It is benefit to all of us. We are a benefit to our own fellow human beings. So this is vast crushed sand in place of river sand. Now see, river sand has become a big concern. Everywhere there is a big concern of sand quarrying. The state governments are imposing a lot of restrictions because of local transportation issues, local pollution issues, local law and order issues, local demands, etc. So the cost of the sand is increasing. The construction companies are not able to afford the cost. So that way, this is a simple, the crushing. Whenever we are using a stone crusher, there will be the powder, the stone dust which comes out, that will be used for in place of sand. Again, that falls under zone 2. Like zone 2 sand is here, also zone 2 will come. Like there will be a lot of silt in that. So that washing will be done. This is also as per IS 383. So washing is done in this process. there will be a reduction of almost 25% of 20 to 25% of this thing. The silt will be eliminated. So you will get a good zone sand from that, from the after the washing. I'll just show you the this thing. This is the water recycling, thickening, flocculation, initial washing. Then if you see, you see the power cost. See how, if you go with this thing, how much of saving in there in this. Almost 835 rupees is saving vis-a-vis the conventional sand per metric ton. You see the process. I'll come to the, this is the typical this thing. Where is it? Not this one. Where is it? I think, you see here, this is the sand washing this thing. So that entire crusher dust after crushing of the stones, that will fall in this. So all the waste will get eliminated from here. It will go to the brick industry, and all the water, the water which is after the filtration process is over, that will be gone for the recycling. It will again be used, and the finished product will be used for the concrete purpose. So there is a saving. As I said, there is a cost saving, and also you are not depending upon the river sand. That is the biggest advantage here. So people think that initially investing in that what they call that plant, the plant may be some 3 or 3.5 crores, but that plant can be used for 3-4 projects. So the money what you're saving is much more than the cost of the plant. So people should not think about the initial capex. Capex means the capital expenditure. That will be only an initial investment. It is not going to cause any harm to your budget, but in long run it will give you a lot of benefit, and your dependency on the local sand also will come down drastically. See, electricity, you can replace your generators. As I said, I already spoke. Just I'm coming to the concrete. If you use plant directly electricity produced from the from plants, from electrical sources, from generation, you see the cost. It is in diesel generators you're using, its pollution. It costs a lot of pollution, and per cubic meter, if it is costing 67 rupees per unit, here it's coming to 45 rupees. In wet mix, it is coming to 8 rupees 995. It's 6 rupees saving. In hot mix plant, it is 10 rupees saving. In crusher, it is 26 rupees saving. Huge saving when you're using LCT from the what you call substation. So you have to apply, and you have to pay per the unit, but there's a lot of saving, and there's no pollution. There's thin white topping, and nowadays you are seeing the white topping and the thin white topping in cities. This is a growing demand. I am not going too much of details because of the time constraint. I'll tell you in a short. This white topping is widely practiced in the cities to keep the road pothole free, and also to maintain a uniform riding quality, and it will give a good finish, and it can be done overnight without affecting the traffic. One lane can be closed during night, and the tin topping, and next to the traffic can move. So the advantage of and it is also eco-friendly. You can see, and this thin white topping is always in small panels. In PQC, where we do large in the rigid pavement, in the heavy roads, in the express highways and all, there the thickness is very high, 350 to 400. But here it is only 100 to 150, maximum 200 thickness. The panels are also small panels, 1 meter by 1.5 meters or 1.25 meters. So there is no longitudinal bars or transverse bars, no dowel bars. Only a sheet will be provided. So you can see the difference. the crust combination, the difference of the thin conventional white topping and thin white topping. You can see the cost, there it is 63 lakhs, it is here 36 lakhs, there is a saving of 26 lakhs. Then mastic sheets. Mastic sheets are of course used in the construction of the highways, bridges and all, widely used. It is being used in every project in the country. This, earlier we used to use the, what you call the mastic asphalt. You have to have a hot mix, you have to mix the sand, you have to mix the, you have to heat the bitumen, mix it, lot of pollution, a lot of labor, a lot of injuries, so much of eye contact, so many problems were there. Nothing, now just lay this membrane, just lay it and fix it. Very simple solution. So, and this is also, very cost effective. You see, for 1 kilometer, the mastic sheets, there's a huge saving, 68 lakhs of saving. If you go with the conventional method, is time taking, labor oriented, pollution, injuries, so many negativities are there, but here everything is positive. So I had to conclude it quickly. I wanted to have a very detailed this thing. Let me read out the conclusion. As its core, the debate between conventional and innovative concept is not about declaring one approach superior, but rather about choosing the right tool for a specific problem. Innovative concept focuses on new user-centric solution to challenge the status quo, while traditional concept builds upon established time-tested principles to provide stability and reliability. The most successful concept often result from a thoughtful blend of both methodologies. So that's what I was telling to the young generation and the faculty and the learned professors and the intellectuals and who are present here to do that. Then innovative user-centric solutions, competitive advantage, rapid adaptation, and environmental sustainability. So thank you all. I hope I have not bored you all. So I am open for questions, and I would request you all to put some questions so that it will be easy for me to go.
Thank you, sir, for your valuable insights. We extend our sincere gratitude to you, Mr. Ramesh Singh, sir, for your insightful and engaging section during our faculty development program. Your expertise, clarity, and thought-provoking ideas have truly enriched our understanding and inspired us to enhance our teaching practices. Thank you for a valuable time and contribution, sir. If anyone have questions, please ask.
Most welcome, madam. I will look forward to the questions from the members.
Okay, sir.
Now I request all the faculty who are attending from various parts of the country, please ask questions to the renowned expert from industry. He can answer you. If you have any question, you can just post in the chat box or you can directly ask. Yesterday, so many questions are there yesterday. So someone asked, can you read out?
Yes, sir. Does geocomposite material question is gone again?
Sir, I will read. Sir, does geocomposite materials can be used for MDR, VR roads?
Yeah, it is. See, I want to tell that, I want to answer that gentleman that that it is very much possible to use it for major district roads, the village roads. That's what I have been telling. There is a lot of potential. There's only in the highway sector, other than the major district roads, the rural roads, etc. There is that if I add that that length, it will be more than 10 lakhs kilometers. So there's a lot of potential where we have to use these geocomposites. See, you can avoid the stone coring. You need not bring the GSB. You have to get this HDP material of geocomposite, straight away spread it. You don't need any much labor also. 1 to 2 people are enough. They will handle it and they will spread it and fix it. So easy it is. That's what I have been stressing upon.
There is another question, Ramesh. There is another question. Why don't every state of India applying this for road construction?
It is being applied. See, now what is happening in many of the states, the respective R&B departments, the roads and buildings, the PWD department, like in Mumbai, the MSRDC is there, Maharashtra State Road Development Corporation. Then in Karnataka, the KRDC, Karnataka Road Development Corporation. Like that, each state has its own road development division. They are all including in the contract specifications. They are telling that you can go with the geocomposite as well, because of the stone aggregate crisis, because of the quarrying restrictions. For the same government is imposing quarrying restrictions, and that's why they are also giving the opportunity to the construction companies that if you have a shortage of aggregates, you can go for the geocomposite, and that is again as per the design. It is not just at whims and fancies. It is again as per the design. The crust will be designed as per with the IIT pave design. There is an IIT pave design. In that IIT pave, this entire crust will be designed. And once the design is completed, it will be verified by the third party. And after it is approved, it will be put up to the client, the department, and the department will approve. Then the contractor will use it. So there is a process involved in this. So every state government is using in the contract specification itself.
One more question is there, sir. Sir, I had a doubt in the steel fiber reinforced concrete. Steel bar reinforcements should be used or not?
No, there will be no more reinforcement. That is what I am telling. It is only fiber particles. That 0.2 mm to 13 mm, that itself will be there. And I have already shown you that it will be some 37 kgs or something in a mix. So that's all. There will be no reinforcement, no rebars, no more rebars. It will eliminate the entire reinforcement steel. For one cubic meter of mix, 157 kgs of steel fiber bars will be used. So there is no requirement of any more steel rebars. I am making it very loud and clear. And the biggest takeaway is it can go up to more than 100 meters of span.
Okay, sir. Next question, sir. What aspects we need to focus while selecting grade of manufactured sand from your practical experience, sir?
Sorry, repeat the question.
What aspects we need to focus while selecting grade of manufactured sand from your practical experience, sir?
Yeah, I understood. See, the aspect is first thing is the availability of the river sand. See, if there is the availability of river sand, there is no local problem, there is no local government issue, there is no local Tahsildar restriction, and the quality of sand is good. It is falling in the grade zone 2. Suppose it is, and all this parameter you can use. If suppose the cost is very high, the distance from the construction site is very long, 40 kilometers, 50 kilometers, and the transportation time will be very high, cost will be very high, time will be very high, and all these factors have to be looked into. So, and of course, if you see, I'll give you an example. Take a project. Say there is a 1 lakh cubic meters of concrete to be poured in a project. So in 1 lakh cubic meters, how much of sand is required? Say we required 1.5 lakhs cubic meters of sand. Example I'm telling you. Suppose for 1.5 cubic meters of sand, suppose you are bringing it from the river sand. Suppose it costs you say 15 crores, and suppose you're doing it with what you call washed sand, with the crusher that you putting a setting up, and with all including cost of plant and everything, if it is over by 10 crores, you're saving 5 crores. You're saving, and forget about 5 crores. You're having a lot of time saving and no headache. Am I clear?
Yes, sir. Next question, sir. What about the use of geosynthetic material in hydraulic structures?
See, hydraulic structures, the geosynthetic material, what I mentioned earlier is, see, first thing is the application is specifically designed for avoiding the filter media. See, what happens is in any retaining, see, water retaining, soil retaining, all the structures, especially water retaining and soil retaining structures, the possibility of water passage is very high. Even in soil also, suppose there is a, if you construct a retaining wall and there is a soil one side, and there's a lot of water and rain and flooding and all, and what happens, water will pass on. What is the purpose of filter media? The water has to escape through the filter media. It has to go to the perforated drain at the bottom, and it has to escape outside, and it can be used for conservation of water. So what will happen in these particular cases? You need not depend upon the quarrying, bringing the stone from somewhere and using labor. For all these things can be eliminated. So the hydraulic structures, water retaining structures, you can use these geosynthetics. I mean what you mentioned, and it is time saving, cost saving, eco-friendly. Am I clear?
Thank you, sir. Next question, sir. What is the methodology used for design of structure if we utilize steel fiber?
Sorry?
What is the methodology used for design of structure if we utilize steel fiber?
See, again, design is governed by the French code. You remember I had mentioned about the French code. There is a French code. I can share that code later on. As per the French code, the design, there is a design methodology as per the French code. The French code is NF P18 710 and NF P18 470. These two codes will give the total, they lay down the total procedure of the design. See, design methodology is always same. I want to tell all my viewers and friends, though I am not a designer, as I said earlier, I am like a general physician. So design concepts are same. You have to take the first, the what you call soil characteristics. That is, the geotechnical investigation is done first and foremost. Then the soil characteristics are known. What is the bearing capacity? All those things are ascertained after the geotechnical investigation. After that, you will know what are the loads, different types of loads: wind loads, seismic loads, dead load, live load, and maybe what you call hydraulic loads. Means when floods are there, or hydrostatic forces, all these loads are taken into account, and this structure will be designed. The principle is same anywhere in civil engineering across the world. The principle is same. Only thing is, since this particular GFR, this ultra fiber reinforcement concrete is a very high grade concrete, M150 grade concrete. So the French code will give you more detailed steps what to be followed while designing, but the principle is same. So as I said, the IRC code is yet to be introduced in this country. It is when I entered with this the manufacturer, they said that it may happen in 3 to 4 months. But I think at least within next 6 months, this IRC code also will be available. So you can follow the IRC code. You can follow the IRC code and you can carry out the design. So that is it. Any doubts in this matter?
No, sir. Thank you, sir. One more question is there, sir. But no one and nowhere it is utilizing this material as it saves too much money. What is the reason?
Which material you are telling?
Sir, जो steel bar, sir.
So you are talking about the
Steel
ultra
fiber,
fiber.
sir. Steel fiber, sir.
No. It is widely being used. It is used in across the country in many structures. It is being used in Delhi Metro. It is fabricated. It is manufactured at Pune and transported and taken to Delhi. We have used from Pune. We have used in Himachal Pradesh. It's being used, widely used. See, again, I'm telling you, the people should appreciate and understand this span. The most important thing is span. When your span is increasing, your normal TSC eye girders will be restricted. You cannot go for eye girders more than 50 meters. Nowadays, maximum they are using is 50 meters, 45 to 50. Beyond 50 meters, it is not sustainable. So, for long spans, you can go with this type of ultra fiber reinforced concrete beams. So it is widely being used. I have shown the photographs. No,
Yes, sir.
I have shown where it is being used. The practically which project, name of the project also has been displayed.
Yes, sir. Next question, sir. Can recycled aggregate concrete meet the structural requirements of pre-tensioned bridge in high moisture environments?
Can you type the question there? I could not understand
Yes.
that.
Again, I repeated, sir. Can recycled aggregate concrete meet the structural requirements of pre-tensioned bridge in high moisture environments?
Just wait. Let me.
Can I read, Ramesh?
Yeah. One second.
Can recycled aggregate concrete meet the structural requirements of pre-tensioned bridges in high moisture environment?
Yeah, very much. See, again, I'm telling you, there is nothing. See, it will be more advantages in high moisture. Why? Because I'll tell you, it is impermeable. The word I'm using, impermeable. If you see in my presentation, I have also mentioned about the impermeable property of this. It is highly impermeable because of its impermeable. It is very much applicable. And since the fiber, what you call steel fibers are copper coated, it will be corrosion resistance. There will be no oxidation process, and it is very good. It is and it will be more advantageous using in where there is high moisture content, because it will be less susceptible to the oxidation process because of the less permeability. Because what happens, the bonding of the material will be much more than the normal concrete. There will be no voids. That is the big advantage.
Thank you, sir. Next question, sir. How do you see the future skill requirements for civil engineers changing with the integration of smart and sustainable materials?
See, I will tell in one word, for all civil engineers, I am not undermining other branches. All branches are equally important and very valuable. Every branch contributes, but civil engineering, I'm telling you, the future is like the future is going to be like a lottery ticket. Just that is the future for the civil engineers. So much of potential is there for civil engineers, and especially in the sustainable materials, eco-friendly, durable civil engineering practices. Those who are practicing these, there will be hotcakes in the market. Those who have knowledge on this, they will be given highest importance and highest. They will be the high-paying salary people in the market. I am telling you, take it from me. Today's requirement for the construction companies is those engineers who are acquainted with innovative construction practices, and who are, see, somebody may not design it, but even if he is using it, like you take my case, I have used it. I know in and out. I know the commercials. I know the time cycle. I know the technicality. So like that, if the young engineers are able to practice using these kind of innovative techniques and methods, there will be hotcakes in the market. The future is abundant. I am telling you, for the infrastructure, as per the NITI Aayog, I do not know, recently I read some article, only in the infrastructure sector, the investment is next 5 years. Then the investment is going to be the tune of nearly 100 lakhs crores. That is the plan. That's the plan. Even if 10% is happening, that will be nearly 10 lakhs crores. That is the initiative of the government, and it's happening. So for civil engineers, see, I will tell today. Earlier, once upon the people used to say, "Are civil engineering what?" and nothing like that. Civil engineering is going to be a permanent pillar in the engineering field forever, until this earth is there in this universe. So there is no dearth of any what you call professionalism or shortage in this.
Okay,
Yeah.
sir. Thank you, sir. Next question, sir. As you have mentioned about the guideline of using fiber composite in IRC code, how they come up with guidelines, which test and number of sample tests in the field are they performed?
See, as you have mentioned about the guideline of using fiber composite in IRC code, how they come up with the guidelines, which
Yes,
tests and number of sample tests in the fields are they performed. See, actually, I'll tell you, the IRC, the Indian Road Congress, they use the CRRI. CRRI is the Central Road Research Institute present in New Delhi. Its headquarters in New Delhi. They have a branch in IIT Roorkee also. So what they do is, for all the new applications, so new techniques, new methods, new procedures, new methodologies, they will refer it to the CRRI. CRRI has very innovative labs. If anybody has visited Delhi, please visit CRRI. You can even your college can depute people, write to the director, and they can go. There will be labs, huge labs. So they conduct a lot of tests there. There are some methods for conducting tests. They conduct cyclic tests, simulations. They do a lot of tests, and they will produce those results to the IRC. Then IRC, based on the results, they will again give it to the third party design engineers. Their design engineers use all that data, and they'll do the design. Again, they'll give the results, the design, the final design report to the IRC. Based on all these things, they will incorporate as a code with certain clauses in the IRC. This is the procedure.
Okay, Sibani, you can start
sir.
the next session. You can ask. The time is up. Okay, 7:40 now. Another
No,
session.
Gopi, I'll take 5 to 10 minutes break, because
Okay.
just give me 5 to 10 minutes break, and then we'll start the next session.
Okay.
So now it's 7:41.
Hmm.
We will start it at 7:50.
Okay.
Is it okay?
Okay, no problem.
Yeah.
Uh,
Thank you.
let them start at 7:50. Okay.
Yeah. Thank you.
Okay. And what about Shivani?
Yes, sir.
You can restart at 7 because let it continue. Those participants are there. Let them be
Yes.
there
Yes.
and let them rejoin by 7:50. Okay.
Yes, sir.
You are giving attendance sheet separately, no?
Yeah. What?
No, no, not you.
Yes,
Shibani,
sir. Yes, sir.
you are giving attendance sheet separately, no?
Yes, sir.
Okay, right, right. Okay.
Participants are requested to provide their valuable feedback and attendance by clicking the pinned link in the chat box or below or by scanning the QR code shown here in your screen. Full start, sir.
Yeah, once again, good evening to all of you.
I request our expert, Mr. S. Ramesh, sir, please take over and begin the 8th session of this FDP. Thank you all participants and support.
So this is entirely a different topic. We had earlier discussed about the sustainable new generation materials. Now, this is also something related to ESG, and it is for the airports. So just I will start with my slides. Just it is. Are you getting the full screen now?
Yes, yes.
Yes, sir.
Okay, see, we had to spend considerable time in the first session. Second session will be little shorter. I want to make it a bit shorter, and we'll be more concise to the subject. And second thing is this subject has been prepared by me in a very short notice. However, I'm confident that I will make the presentation in a convincing manner, and I'll be able to attend to the questions as well. Thank you, and let me start. So this is about sustainable materials in airport construction, terminal and runway innovations for low carbon delivery. This is also an interesting topic. So these are this is the agenda of the thing. The opening session: sustainable life cycle assessment, terminal structures and shell, terminal interiors, runway, taxiway, airside concrete payments, subways, base and drainage, airfield lighting, ancillaries, procurement certifications, roadmap and call it to action, closing. If you see, these photographs are for, the latest airports, modern airports. See, in a brief, there are about 40,000 airports across the globe. Only 9,000 airports are serving the commercial airlines. And if you take the case of India, there are 487 airports, out of which 123 airports are for commercial purpose. And there has been a significant increase in doubling the number of airports between 2014 and 2023. So the expansion is part of government-led effort to improve aviation infrastructure and promote affordable air travel. So you might have seen the UDAN scheme. In the UDAN scheme, the government has taken steps to provide airports in small towns as well. So that way, people are able to travel in a shorter time with an affordable fares from one destination to another destination. So the opening session, the new generation airport materials include smart and bio-based composites, advanced waterproofing systems, high performance asphalt and concrete, and innovative recycling sustainable materials like recycled aggregates and dredged river material. There is also a growing use of lightweight materials for formwork and structural components, and the development of fabric structure for roofs and walls. See, why sustainable materials? Reduce global emissions. What is global emission? Embodied carbon in concrete, steel, asphalt, responsible for nearly 11% of global emissions. You just see this statement. 11% of global emissions are because of concrete, steel, and asphalt. It's a big number. So we have to minimize it. We have to reduce it. Then the life cycle cost. Life cycle cost is also a very important statement. Adopting sustainable materials, airports can reduce life cycle cost by 20 to 30%. 20 to 30% cost is getting reduced because of adopting sustainable materials in airports. The life cycle cost. Then compliance drivers. The compliance drivers is one of the most important things. As I said earlier, the ESG, lead. This is related to ESG. All are related to the ESG. LEED means leadership in energy and environmental design. It is widely used in the United States. Then Envision is also one method of certifying. The San Francisco International Airport has been certified by Envision. Griha, that is again India. Griha is green rating for integrated habitat assessment. Then case study, Oslo Airport became the world's first airport to achieve BREEAM certification with extensive use of recycled steel and low carbon concrete. What is BREEAM? BREEAM is Building Research Establishment Environmental Assessment Method. So that is the first airport in the world. The resilience example is Singapore's Changi Airport integrates flood resilient drainage systems and heat reflective roofs to combat climate change. So this is the innovative methods they are using in various airports. So the life cycle assessment. A life cycle assessment is a science-based methodology for evaluating the full environmental, social, and economic impact of a product, process, or service from raw material extraction to end of life. It involves 4 iterative phases: define the goal and scope, conducting a life cycle inventory to quantify inputs and outputs, assessing the potential impacts on human health and environment, and interpreting the results to identify areas of improvement and more sustainable design. So as a carbon emission is life cycle assessment tools to measure carbon emissions from material extraction to end life. From material extraction to end of life. Then use of fly ash, which we discussed earlier, that will reduce by 30% of the carbon. Case study, Heathrow Airport in London. The life cycle is assessment, modeling for its new runway, enabling 25% reduction in life cycle energy costs. Life cycle energy costs. So the key point is life cycle assessment helps in benchmarking, policy compliance, and tracking net zero progress. That net zero progress is very important for the ESG compliance. So some more interesting factors: terminal structure and shell. So terminal structure and shell. If you see the terminal, if you in any airport, see generally airports have two areas. One is the land side, one is the air side. The terminal structure comes in the land side. So the low carbon concrete mixes using fly ash and GGBS, which we discussed in the earlier topic. The modeling, recycled steel with optimized designs using BIM, building information modeling. Then reduction in construction emission, mass timber, CLT, cross-laminated timber for concourses and canopies, cutting construction emissions by 40%. Using cross-laminated timber, it reduces the emissions by 40%. Cool roofs with recycled aluminum facades. So see, if you see Bangalore Kempegowda Terminal 2, it has adopted bamboo and locally sourced aluminum facades, branding it the terminal in a garden. So it is the first airport in the world using this bamboo facade. I do not know how many of you have traveled to Terminal T in Bangalore. I'm sure many of you have traveled. It's very, very elegant, and you can see all this innovative, low carbon sustainable materials have been used over there. So again, coming to that low carbon concrete, it utilizes supplementary cementitious materials. We call it SCM, like fly ash, slag, silica fume, to replace a significant portion of traditional Portland cement. Thereby reduces carbon footprint. SCMs lower the amount of energy intensive clinker required, which is the primary source of CO2 emissions in concrete. This is not only decreases environmental impact, but also enhances concrete durability. See, it reduces the CO2 emissions and also enhances the concrete durability. That is the beauty here. Then rice husk ash, RHA, another SCM that can be used. RHA is a byproduct of rice production that adds cementitious compounds to the mix. Then recycled aggregates, incorporating recycled aggregate materials from construction and demolition waste into the aggregate component of the concrete mix reduces the need for virgin materials. Example, I'll tell you, if you are demolishing a big concrete structure, you can extract all the waste steel, you can remove all the concrete, set concrete, all those things can be separated. And you can take out those you can take out you can make recycled aggregates from that, and you can use it again. You can use it for the new mix design, carefully adjusting the mix proportions, including water cement ratio. It will influence the compressive strength, durability, the rate of the cement's hydration. So all these things factors will get impacted. Then we discussed about crossed laminated timber. It is an engineered wood product. Wood is totally a green product. So wood product made by gluing multiple layers of solid sawn lumber at 90-degree angle to create large high-strength structural panels used for walls, floors, and roofs in buildings. You can see the benefits here. It's totally a green product. What is timber? Timber is it's directly from the tree. Tree is what is a green product. Bamboo facets. Bamboo is durable, fire resistant, and a natural look. Is stable and is available as boards or beams and easily to maintain. It has been used in Kempegowda International Airport Terminal Building 2 in Bangalore. Then recycled aluminum. Recycled aluminum is a aluminum that has been processed from scrap and end-to-life products to create new aluminum products using significantly less energy than virgin aluminum production. Then terminal interiors and fit out. So in terminal interiors and fit out also recycled material like tiles, terrazzo, and modular flooring systems. Indoor pollution, low VOC. Low VOC means this generally whatever paints we use in our houses and buildings, and they're all volatile organic compounds. If you see when they're new painting, there's a lot of smell and a lot of sneezing and eye burns and all will be there. So you can use low VOC paints. Then natural light, daylighting with high performance glazing. High performance glazing, that will give you more lighting. Smart LED. Schiphol Airport, Amsterdam, in Switzerland, pioneered lighting as a service with Philips achieving 50% lower energy cost. 50% has been reduced with the smart LED lighting. Then case study is there in Hyderabad Airport also. Interiors using 40% recycled materials and advanced glazing, cutting, cooling, load by 18%. Using 40% recycled materials, so it has come down by 18%. Then recycled terrazzo, it is sustainable composite material that incorporate recycled materials such as marble cutoffs, glass, or even plastics with a cementitious or polymeric binder. You're using all this glass waste and all those things with a polymeric binder. Again, you're using this terrazzo materials. So again, you're minimizing the waste products, and it's more eco-friendly, cost-effective. So many advantages are there here. Then LED lighting. It provides airports with significant energy cost savings through high efficiency and long lifespan. Enhance passenger and staff safety with better visibility and fewer maintenance risks, and improve passenger experience by creating welcoming, dynamic terminal environments that meet sustainability goals. VOC paints, as I said, it contains volatile organic compounds that evaporate and release fumes into the air as paint dries, causing the characteristic new paint smell and potential health issues like headaches, irritation, nausea. So use low VOC paints. It contains less volatile organic compounds than traditional paints, typically less than 50 grams per liter and off gasless. So that is the advantage. Daylight glazing. Daylight glazing transforms, see, you can see the photograph. So how the daylight glazing transforms spaces with natural light, beautiful look, providing functional and elegant glazing and focus on quality, creativity, and satisfaction. So these are all innovative thoughts, innovative adoptions in the industry. Now coming to the air side, the runway and taxi asphalt options. See, the warm mix asphalt. It reduces energy by 20% and cuts emissions, widely deployed in the US FAA approved projects. Reclaimed asphalt, we discussed in the earlier session, RAP, which saves cost by 15 to 20%. Then modified binders. This also was discussed. This is used in Indira Gandhi Airport in Delhi. There is tested crumb rubbered asphalt, reusing thousands of waste tires. Thousands of waste tires have been used here in Seattle. Then coming to warm mixed asphalt, this method involves using foaming techniques, chemical additives, organic additives to reduce the viscosity of the hot binder, bitumen binder. This allows the asphalt mix to be produced and worked at lower temperatures compared to the hot mix asphalt. The RAP, we discussed earlier, this mix is an asphalt pavement mixture that incorporates RAP, a sustainable, cost-effective material where RAP can improve rutting resistance. Its use, especially in higher percentages, can negatively impact fatigue and thermal cracking resistance due to the aged hardened bitumen. To balance these properties and enhance durability, the regenerator, wet bonds REX is added because the RAP material will be aged. It will have negative impact fatigue resistance. So for that, this wet bond REX material will be added as a regenerator. Then the crumbed CRMB, they call it CRMB. It is specialized binder for asphalt made by blending recycled the crumb material. This process creates a more durable, flexible, resilient binder that enhances asphalt performance, offering increased resistance to high temperature deformation and low temperature cracking. It is an environmentally friendly solution that supports sustainable construction by utilizing waste tires, and it is widely used in heavy traffic applications like highways, airport runways. I want to tell you one thing here, that why we are going for flexible pavements, why we are not going for rigid pavements in the runways. See, in the air side, all the runways will be flexible because the landing, while landing, there should be less wear and tear. That is the main thing. And there are other benefits also. But if you have a rigid pavement, it will be when the aircraft wear and tear will get affected, and landing also will not be smooth. That's where they go. Only the apron will be the PQC, the rigid pavement. That is, we call it the rigid concrete. So the air side will be two parts. One is the flexible part and the rigid part. All the taxiway will be the concrete, and the runway landing and takeoff will be the flexible part, where we have to use this. We use this bituminous mixes for optimizing the cost and for making it eco-friendly. We use this RAP material, CRMB, etc. See, Geopolymer, the other day, one of our resource members was, I think, if I remember, is Dr. SP Singh, the NIT Rourkela. He has given a very good presentation about the, I think, geopolymer concrete. It was very interesting. So I am not going with so much of depth. I am only giving you just a macro level information about the geopolymer concrete. So geopolymer reduces carbon footprint by 80%. You just imagine, it is reducing the carbon footprint by 80%. But of course, it has some limitations. Then the SM tenere, the sustainable cement material. This is again blends provide higher durability. Mineralized concrete, carbon dioxide mineralized concrete happened Canada's Toronto Pearson Airport apron works. See, as I was telling, they have used in the apron works in the Canada Toronto Airport. Then recycled aggregate improves cost efficiency. Then Brisbane in Australia Airport trialed geopolymer concrete in taxiways, showing strong performance under jet loads. So the product is geopolymer concrete, aggregate, then additives, activator, fly ash. It's a combination of all these things. It is a sustainable, cement-free alternative to Portland cement, made by reacting aluminosilicate-rich materials like fly ash or slag with an alkali solution. That day, the professor, Dr. SP Singh, was explaining about the alkali reactions and all. He has given a very detailed explanation. I hope many students might have understood that. So that's what this says. It offers benefits such as high compressive strength, superior durability, chemical resistance, reduced carbon emissions by utilizing industrial waste. You are using the industrial waste, so obviously it reduces the carbon emissions. So the air-side concrete pavements, the carbon dioxide mineralization in concrete involves the permanent conversion of CO2 into stable mineral forms, such as calcium carbonate, within the concrete structure. This process acts as a method of carbon capture and storage, capturing CO2 emissions from cement production or directly from the atmosphere and locking them into building materials. The integration of CO2 mineralization not only helps the sequester carbon, but also enhances the concrete strength and durability. So you can see the right bottom, you can see the PQC. That is the pavement quality concrete. It is used in roads also, where there is a rigid pavement. This is used in the web apron. So again, SCM, it refers to a concrete mixture containing 3 different cementitious materials, including Portland cement, supplementary cement materials such as fly ash and silica fume. This practice enhances concrete properties like strength, durability, workability by creating synergistic effects, filling pores and forming additional binding phases. Linear mixtures are a key component of high-performance sustainable concrete, offering benefits like reduced environmental impact and increased durability. See, I want to go back to this slide. See, when I was talking about the runways and all these things, I do not know how many of you are aware. In the recent past, in the last 5 years, the National Highways Authority and the Ministry of Road Transport and Highways, they started developing the emergency landing in highways, in express highways. In Andhra, between Nellore and Tilbet, one emergency landing has been constructed. It was done by my earlier company. And now, we recently in our Adani, when I was there in Adani, we completed one in UP, Ganga Expressway, which is a 450-kilometer stretch. There also one emergency landing on the highway itself. The highway itself, they have developed an emergency landing strip, A strip. Then similarly, between Delhi and Agra also, there is an emergency landing strip. So all these A strips are being developed for emergency landing purpose. Because tomorrow during adverse weather conditions or during war or during some other catastrophe or because of natural calamities or force majeure situations, these emergency landings will be required. So you need not have a separate A strip for that. You can use the existing highway itself for the emergency landing. So how, see again, in the air side, what I was telling, the runway, again, it will have subbase, base and drainage. Drainage is very, very important. When, like, in Mumbai airport, when Mumbai is prone to heavy rains and sometimes the rainfall is even 50 centimeters, 60 centimeters, 80 centimeters. So it's such a, dense rain occurs here and it floods the entire area. So proper drainage is important. Otherwise, if the aircrafts are suspended, there are a lot of loss to the traffic, to the aircraft operators, the airport operators, everybody is, and people also who have planned their meetings or they're traveling in an emergency, everybody will suffer. So proper drainage is important. So here again, they have to be properly designed by using all these sustainable materials. As I said, recycled aggregate, cement treated foam stabilized recycled aggregate, and then permeable shoulders, where if you use permeable shoulders at the edge of the drains, water will automatically escape and they will pass through the drainage provided and it will escape to the location, and you can do water conservation also. You can see in the airports, there will be some surface drains. All those drains are for this purpose only. So geogrids are also used. Earlier, somebody put a question whether we can use in the water retaining location. These are all geogrids and all are used. It's used in Mumbai, in T2, in Mumbai International Airport. It is reduced aggregate by 25%. And Dallas in the US, Fort Worth Airport implemented recycled plastic drainage pipes to increase durability and reduce costs. So these are various practical applications. Then cement treated foam stabilized recycling. This is another method. It improves concrete by enhancing its microstructure and strength. Foaming creates a lightweight porous structure, while cement and recycled aggregates, low concrete waste, provide the essential binding and skeleton. leading to a denser, more sustainable material. This combination offers environmental benefits by utilizing waste materials and reducing the carbon footprint of traditional concrete production. Subbase, base and drainage. You can see the, let me show the pointer. You can see here, this is the shoulder portion, this is the permeable portion. So you can see the drainage pipe here. It will be a perforated drainage pipe. So when there is a heavy downpour, either it's an airport or a road or anywhere, the water will, when it is, some water will escape from this, there will be a slope drains that will escape to the desired location, or the water which is locked here, that will pass through the permeable, it will enter into this pipe and it will go to the desired location, wherever it is designed. That is the, so the design, the designing of these things is very important. And you can see the crust, the subgrade, subbase, base, all this, the crust. And this is the shoulder portion. So here you can use the permeable, the shoulders. It integrates an open graded aggregate base with perforated under drain system to manage storm water, whereas conventional drains primarily capture surface runoff from rigid pavements. The permeable drainage shoulder system allows water to infiltrate vertically, slowing its movement before drainage via the under drains and infiltration to the drain. So this is the advantage here. Then there is a geogrid. In runway construction, geogrids are, if you see in the airport runway, geogrids are synthetic polymer materials that reinforce the pavement base and subbase, improving stability, reducing aggregate thickness, and extending service life by interlocking with the aggregates to form a mechanically stabilized layer. These geosynthesis increase the load-bearing capacity of subbase base, distribute stress more efficiently, and prevent rutting, cracking, and deformation under wheel loads, making them a cost-effective and sustainable solution for strong and durable run. This, you can see the photograph, the practical application. It's very easy. It's very easy. Just spread it and lock it. That's all. So next we'll go to the airfield lighting. This is very, very important. LED lights, transmission LED, AGL systems up to 70% of energy savings. Just imagine using LED lights, it will enable 70% of savings. Again, case study, the Schiphol airport transition to 100% LED light, cutting 50% operation cost. So the budget what they had in the LED lighting, that was cut down by 50% of its cost. Then composite mass and trace reduce corrosion life cycle costs. Then solar ready rooftops. As I said earlier, Cochin International Airport, they used a 50 megawatt solar roof-based solar power plant there. 50 megawatt is in airports is a big capacity. You can see the typical LED lights. Airfield lighting uses less energy, lasts longer, and integrates smart systems to guide aircraft safety and so optimize traffic flow. These are the composite mass. It is made from materials like carbon fiber and fiberglass. Again, they are sustainable materials, offer a lightweight, strong, and durable alternative to traditional metal mass, making them ideal for tactical, airport, marine, and utility applications where performance resilience are critical. Air rooftop solar panels, what we discussed earlier. This is the typical one in the Cochin International Airport. See, this is one important aspect. So nowadays, all the airports, they are looking into these aspects. Now, suppose now in India, the airports are broadly, if you see in the administrative perspective, they are classified into two: the government run airports, the private airports. Like GMR, Adani, GVK, they are running the private airports. GMR is running the Delhi airports, both T1, T2, and T3, and Hyderabad T1, only one airport, international and domestic. And now they are constructing a big international airport in Vizag at Bhogapuram. And Adani is running the airports in 6 locations: Ahmedabad, Mangalore, Delhi, and Jaipur, and different locations. And GVK, earlier it was running in Bombay, now it is taken over by Adani. So all this, they are private and government. But why I'm discussing these things is that these certifications are very important. Based on these certifications, the funding will happen. If I want to construct an airport, the lender, the bank, the ADB or the World Bank, they will see whether these things are certified or not. Then only they are ready to certify. That is again ESG compliance. This part of ESG compliance. So EPDs and LCAs, mandating vendors to provide EPDs and LCAs. Local sourcing policies. Istanbul airport was constructed by GMR in Turkey. It has increased the regional employment also by 20%. Then digital dashboards for monitoring carbon in supply chains. Digital dashboards are being developed for monitoring the carbon in supply chains. Then LEED certifications. See, EPD is environmental product declaration, LC is lifecycle assessment, IGP is Indian Green Building Council. So all these certifications are very crucial. So without these certifications, the lenders, the bankers, they will not be funding for the investment of the private airports or even the government airports also. The government also is taking a lot of loans and all for developing new airports or new highways and all. So everywhere they are looking into the ESG compliance. So this is part of the ESG compliance. So again, there's a LEED Gold certification. It is LEED Gold means it is a certification level within the leadership in energy and environmental design. Green building rating system awarded to projects that earn between 60 to 79 points, meeting rigorous standards for sustainable design, energy efficiency, and human health. Those who are getting 60 to 79 points, they will be getting the LEED certification. And those who are getting LEED certification, the bankers, the lenders, the funding, the ADB, the World Bank, they are trying to encourage, because this is a global concern. So the world eco what you call committees and all, they are very focused on this. So all the money investments are also linked to this ESG compliance. Then the IGBC certification. It is a voluntary green building rating and certification system developed by the Indian Green Building Council to promote and verify the adoption of sustainable building practices in India. Sustainable building practice in India, which we have been discussing last 2 hours. Then the Envision rating. It is a sustainability assessment and recognition system for civil infrastructure projects developed by the Indian Institute, the Institute of Sustainable Infrastructure, ISA, and others similar to LEED for buildings. So these are all very, very, it has become need of the hour. So somebody trying to avoid this thing, they can avoid, but they will not get any funding. So there'll be a lot of restrictions in approvals also. So it is becoming need of the hour. So like, for us earlier, PAN card was not so important. For us, everything today, PAN card is very important. You want to take a loan, PAN card is important. Like that, this is also an important criteria. So this is the roadmap and call to action. Baseline. The baseline of the topic is carbon modeling at design stage. See, this is very important. You have to do the modeling at the design stage itself. You want to implement something at a later date. Again, so many issues will crop up. The cost, the approvals, the technicalities, the contractual issues, so many things come into picture. So you do it at the do it at the modeling, do it at the design stage itself. So that is one important thing. Then second thing is mandating low carbon concrete mix and QOK. So you are specified. Like earlier, somebody asked me a question. Can we? Dr. Gopinath asked me, is it specified and all? I said, I mean, by state governments and all. I said, yes, it is being specified by the state governments. It is being specified in the contract itself. So that mandating low carbon concrete mixes and that is very important. So that at the inception stage itself, it has to be done. Then procure, approved vendor list with EPD, Environmental Product Declaration, complex. For example, Dubai Airport, they have done it. So approved vendor list means only these vendors, only products from these vendors should be procured. Automatically, you will get the green products. Suppose it is there in the contract that it has to be procured from the EPD. Automatically, I cannot deviate. If I deviate, my work will not be certified. If it is not certified, I will not get the payment. So I will have to comply. Now, as I said, yeah, if I have to file the returns, I have to file. Without, I cannot escape. I mean, it is there in the pan. It is open. I cannot do any adjustment. So it is like that. So this has to be mandated at the very inception stage. Then I'll give an example. The pilot trials like Brisbane Geopolymer runway pilot. Say pilot means here it is not the aircraft pilot. It is a pilot project. In Brisbane, in the Australia, the geopolymer was used in the runway. As they did a trial and it was successful. So all these things have to be done at the inception. The very inception you have to do. So that the issues at the later date can be mitigated. So you can see the four: baseline, specify, procure, and deliver. So this is all about, and what we discussed earlier in my earlier, this same thing. Innovative concept, user-centric solutions, competitive advantage, rapid adaptation, and multiple suspension. Thank you all. And I wanted to reduce the time. I wanted to make it a bit shorter than the earlier one. So this is what I can present today. I welcome the listeners and viewers to pose questions. It will be a pleasure for me to answer. But let me tell you one thing, that I prepared it in the last minute. So I'll try my best to answer the questions. I'm not sure, but I'll try to answer. Anyone has questions, please?
Yes, sir. My question is this, sir. Are there any international airport already using next generation sustainable materials?
Yes, very much. I gave you examples. I gave you the example of Heathrow Airport in London. I gave you the example of
In India,
Brisbane
sir?
Airport in Dubai. In India, I gave example of IGI, Indira Gandhi International Airport in New Delhi, being operated by GMR.
Okay, sir. Thank you.
In Bangalore T2, it is being used. It is already implemented. In Hyderabad airport, in GMR airport is also it's already applied. Any more?
Dear participants, if you have any question, please.
I think there are no more questions, Ramesh.
Yes. No problem. Anyone has any questions, they can ask at a later date also. I'll be.
Okay. Yeah, already someone asking question.
Yes, sir.
How construction industry can benefits
How
of
construction industry can get benefit of reduction carbon?
Yes. Very good question. I think Mr. Snehashish Sahani has raised this question. I appreciate your question. Let me answer it. See, the benefits of construction industry is in two aspects. First aspect is the time and cost and the technical benefits. Time, cost, and technical benefits. That is the first aspect. Second aspect is in compliance of the ESG. As I said in my first session, ESG, environmental, social, and governance. So today's requirement is ESG compliance. So the company which is using this material, this new generation eco-friendly material, they will get a benefit of time, cost, and technicality. And also the added benefit is they will become ESG compliant. When they become ESG compliant, they can get more loans. They can get loans at a lesser interest rates. They'll get a better tenure of the loans. So many benefits are there, and their certifications, as I said earlier, LEED certification, all these certifications also will be added to them.
Thank you, sir. Next question is, sir, what would be the thickness of concrete runway, sir?
See, concrete runway
And grade
thickness
of
is.
concrete.
Sorry?
Sir, what would be the thickness of concrete runways and grade of concrete?
See, grade of concrete, see, one thing is there. First of all, the grade of concrete for apron, for runway, there will be no concrete. It is again the flexible pavement, the bituminous thing. For the apron portion, the taxiway, the grade of concrete is normally M30 to M35. That is the grade of concrete. For the apron portion, just adjacent to the runway, the apron will be there. There the concrete will be there. There the grade of concrete will be M30 to M35. And flexible pavement will be as per the crust designed. And some cases it will be M45 also. It depends upon the category of airport. If it is a small airport or it's a big airport, they will take various loads into factor. But generally it will be from M35 to M45. What are the environmental benefits? What is you have mentioned about use of permeable pavement in shoulder region can be used for pavement. Exactly, I told earlier, it is used for both road and runways. In the runway side and the road. In the runway side, if you see when you are flying, when you are sitting in the window seat, you can see to your right or left, wherever you are sitting, you can see the drains. You can see there they use this. And in road also, wherever there is a earthen shoulder, there they use this, not the bituminous shoulder. Bituminous shoulder, again it will become impermeable. Wherever there is an earthen shoulder, there you can use this. Next question.
So what type of parameters which we need to construct an airport, and so is there any chance of bitumen reducing, like replacement, like so, anything would you suggest?
Sorry, if you don't mind, can you repeat your question?
So what type of parameter which we need to construct an airport, and I'm asking about the runway of we are using the bitumen, right? So is there any chance of replacement of something we need to reduce the bitumen, right? It is low cost, I can say.
See, there are two important criteria for the runway design and the road design. There are two important criteria. First thing is, the road is designed, any road in India is designed as per the IIT PAVE. It is clearly stipulated in the IRC. I have shown you various codes earlier. All the IRC has different IRC 48, 50, 50. There are more than 100 codes for designing the road in the for the road part. And when it comes for the runway also, there are codes which are again governed by the MORTH, Ministry of Road Transport and Highways, and also it is governed by the Airports Authority of India. There are certain codes stipulated. So again, in both cases, the crust will be designed. The crust is again designed in both cases, the crust will be more or less similar. First of all, if you see a typical road based on the FRL, suppose some X FRL has been given in the drawing. So considering the FRL, the embankment will be constructed. If it is required, embankment will be constructed. If it is not required, embankment will not be constructed. But the next layers, the subgrade, the GSB, the wet mix, the DBM, the BC, the final, BC is the final. All these are designed as per IIT PAVE. Generally, it will be, suppose if you go for a conventional crust, it will be, say, for a road with a 50 MSA, it will be, say, leave embankment. Embankment is depending upon the FRL that we should not take into consideration. The crust is from subgrade to BC. The subgrade will be, see, it is as per code, should be minimum 500 mm. Then the GSB, it will be some 200 to 250. Then wet mix, 250 to 300 mm. Then the DBM, it will be around 100 to 150. Then the BC, it will be 40 to 60 mm. So this will be the crust. This is depending upon the MSA, how much of traffic is coming. So there is a design methodology for this. They will first assess the 7-day traffic. They will arrive at the MSA. Then they will do they will calculate the VDF, vehicle damage factor, all these things. Then they will put all this data in the IIT PAVE, and the crust will be designed. Same principle applies to the runway. Runway, they will take the dynamic loads, the aircraft, when it is landing, what is the load, all those things will be taken, and they will design. That's all. This is the way they design the crust of the runway and the roadway. Am I clear, or do you have any further doubt?
Actually, in runway, so what type of aggregates we can use? Like nominal size of aggregate, I'm asking.
You can use normal standard aggregate. There is no special aggregates for this. Same crusted aggregate. Only thing is, generally, it is specified to use more rounded material. That is, that for that material, to get a rounded material,
Your voice is not audible, Ramesh. Hello, Ramesh. There will be some network issue. He will be back within 1 minute.
Sir.
Ramesh, is it okay now?
yeah, it's it's okay. So sorry, there was a bit technical glitch.
Otherwise, you can switch off the video. If network issue is there. Hello. You can switch off the video. You can connect audio only.
I switched off. Yeah, I switched off the video. So coming back to that question, so the aggregates are the same. Only we always prefer rounded aggregates. There should be less flaky flaky material. I mean, generally, what there is a limitation that the flaky aggregate should not be used. Like if the flakiness, the percentage of flakiness is more than say 25%, it is not advised. So when the aggregates are crushed, the rounded aggregate, the shape of the aggregate will be more of round. That can happen. See, as I said, the primary crushing, the bigger boulders will be crushed to smaller size. Then it will go to secondary crusher. It will become 40 mm. Then it will go to 20 mm. Then to a 10 mm, and it will get through the bar mech. Through bar mech, it will become more round in shape. More round means it will have more binding between the cement, the mixed proportion, the bituminous mixed proportion. So it will be having more bond. And when there is more bond, the strength will be more. That is the way they use the aggregate. I hope I have clarified.
Yes, sir. Yes, sir. Thank you, sir.
Yeah. Any more questions, please?
Yes, sir. One more question is there. Can we use permeable concrete on footpath too, and can we use it for groundwater recharge in gardens or lawns?
See, you are telling concrete in footpath, and yeah, you can provide perforated this thing. There is another. No, this is a different question. No, the question was you are telling in footpath concrete whether you can use it for what you call the water drainage facility. Huh? Hello. Hello, I'm audible.
Yes,
Audible,
sir.
audible.
Yes, sir. Audible.
No, your question is that in the footpath where there is, if you put concrete, whether you can use it for whenever water or anything ingress happens, whether the permeability or the flow of this thing is possible or not. Is it that question?
He is clarifying permeable concrete on footpaths.
Yes, sir.
Yeah, see, the point is in footpaths are low load bearing pavements. So only a human being will be walking. There is hardly any load. So you can design it with, there are a lot of techniques in this. We can use geoswells, we can use many methods are there. Perforated pipes, so many systems are there. We can use grids, we can use grid concrete. So many methods are there. It's very much possible.
Okay, thank you, sir. Next question is that there is another agency named EIA. How is it different from ESG?
See, EIA is some certifying agency. ESG is not any agency. ESG is a phrase. It is statement. Environmental, social, and governance. ESG is a compliance requirement. I will give an example. Like many people in the industry, they talk Pocklane. They say Pocklane for excavator. Actually, the name is excavator. It is not Pocklane. Pocklane is the company name. Excavator is the technical name. Like that, ESG is the requirement of the government or the bank. ESG is a compliance. EIA is something. It's a certificate. It is some others like LEED, like Griha, like BREEAM. They are all certifying this thing. Like ISO. ISO is one certifying authority. That is different, and ESG different. ESG is a compliance requirement. I hope I could clarify that.
Yes, sir. Thank you. Yes, sir. No more questions is there, sir.
Yeah.
On behalf of the organizing team and all the participants, I would like to extend our heartfelt thanks to you, sir, for your valuable contribution to this session. Your insight, expertise, and engaging the delivery made this session both enlightening and inspiring. The way you presented complex idea with clarity has not only enhanced our knowledge, but also encouraged us to reflect on our teaching practices and now explore new approaches. We truly appreciate the time and the effort you took to be with us and here and share your wisdom. Thank you once again for being a part of this FDP and for making it a memorable and learning experience. Thank you so much, sir.
Thank you all. And
Sir,
Ramesh,
sir,
it's
truly,
one more,
really enlightening.
I
sir,
truly appreciate and thank Dr. Gopinath, Archana Madam, Shivani Madam, and all
sir,
other team
one more
members.
request is there, sir. Participants, please switch on your video for a quick screenshot. Thank you, sir.
Thank you all.
Thank you for your Thank you for your active participation in the faculty development program. Your engagement and contributions made the session truly enriching and insightful. Thank you all participants.
Thank you.
Thank you, Ramesh. Good night.
Thank you. Welcome. Yeah. Good night.
Good night to all of you, all the members, all the participants. Thank you, one and all.